Okay. During the break, they just remind me that I didn't tell the answer to this question. What does this count print? And just to be clear, it will print 1. Even if this code takes a long time to execute, it will print 1 because from line 5 to line 17, there was only synchronous code being executed. And so no asynchronous callbacks have ever had the chance to be run. Okay? So even if it takes 20 seconds here, it will print 1. And then after 20 seconds plus epsilon, when this finishes, we will run the first instance of this interval. So this timer is not a guarantee, it's say a best hope. Okay? If you are free, do that every 1 second. If you are doing something else, okay, you'll have to wait. So this is the minimum amount of time, and so don't use it for making clocks or something like that. Okay? If you want to measure time, use real access to the time functions, the JS.now, and not don't rely, because these are, of course, optimistic values. Okay. So to make some realistic examples about asynchronous code, well, a lot of that will come when we do the front end, because in the front end everything is happening at the same time. Okay, since we are still in the back end, I think the most something that we would really need in any case, and is easy to see, is accessing the database. Because since it's an input-output operation, it will be managed asynchronously. Okay. To make it simple in our architecture, since we don't want to spend too much time or complexity on the architecture on the server side, we just show the simplest solution that we have for managing a database, which is the SQLite library. I don't know if you already know it. SQLite is not a real database management system. DBMS like MySQL or Postgres or Oracle or whatever beast you know are separate processes that usually eat you all your resources and more, and they run by themselves, and they respond to a socket where you can send the queries and so on. Okay, and you need them in a large-scale application, highly optimized and whatever you want. SQLite is a scaled-down version of a database that just runs inside your program. So it's a library. You don't need to have another process, the process of your application, Node.js, plus a process of the database that communicate. No, SQLite it runs inside Node.js, inside your application, and gives you, manages a file, let's say, with a structure like a relational database, and lets you query that data with a version of SQL nearly standard, similar to the standard version, a bit simplified because it's very light. No? And the name also says it's very light. It doesn't create. So when we have when we have the need of some local storage, and we will deal with to have some data and manage it and query it, and we don't want to invent our own format and handle files, because it would be a nightmare. We can use SQLite and create a relational database in a single file. Now, all the table will be in a single file inside our project. Okay, and so the library that is doing that is called SQLite. Actually, SQLite 3, not SQLite. There's a bit of mismatch. Let's be careful. I just did a mistake yesterday. SQLite is the name of the library, and SQLite 3 is the name of the package in npm that you need to install and you need to refer. Okay, and so but we'll see that in a moment. So basically, if we want to use that, we need to create a project with packages, with dependencies. Okay, so you already know, like we did with the last week, now with the JS, we need to create a folder in which we put our project, maybe SQL example. Okay, and we go into this folder. So where am I? I need to exit from node. Where am I? In week 2, SQL example. Okay, once we have in this folder, we need to create an npm project, npm init, and answer some questions. Okay, and I think this, I don't know if you already saw this with yeah, Francesca, it's, if we write module, we can, by default, work in strict mode instead of in normal mode, so we can avoid putting use strict every time, okay? And it would be, so we are slowly transitioning between two different systems of JavaScript modules. Slowly means it's long, 15 years running, but yes. And so it will create the package.json file with the description of the project, and inside this package.json we can install SQLite 3. It takes a while, and it will update the package.json with the dependency, SQLite 3, and also the package.lock.json that will have record actually the specific versions of all the packages that are being installed. I requested from SQLite 3, it brought down SQLite 3, it brought down also other dozen of other libraries that are dependencies on that, okay? But it's just, normally we have to work with package.json. And remember, this, actually this package.json is part of the project itself, contains all the project itself. And also node modules folder has been created with a copy of all the libraries that, okay, I just wanted one, and you had to install all of them. It's always node modules is also a large folder. It's also slow to delete when you don't want it anymore, because there's a lot of file inside. Just remember, if you are going on GitHub, don't commit not folders. Okay, ignore it. Always put. In fact, I didn't do it, all the node modules into the gitignore file, so that it will not be committed. Otherwise, you will be committed hundreds of megabytes every time. And there are many conflicts every time you update, because maybe some libraries being updated and so on. Okay, so you should commit the package.json, package.load, but not node modules. And node modules can be recreated every time, at any time, just by writing npm install. That will parse the package.json, download if everything is missing. So if you remove node modules and run npm install, it will recreate it. Okay, afresh. Sometimes when it gets stuck, you need to do that. Okay, but now we have a folder with this library inside. Let me maybe open, because it's easier, that specific folder. Okay, just because when we do the run, we are running the program in that folder instead of the father folder. I don't know. I not reply. Okay, so what can we do here? How does the database access work? Okay, we have installed the library, we have created a project, and all the data is inside one file that we can, normally I give the SQLite extension or DB extension or whatever. It's just a binary file in your program. So if we create a new program, index.js, import SQLite from the library SQLite 3. Okay, so we have access to the SQLite module, and we can do stuff. The first thing is to create a database and put some data into it. Creating a database means using, if you see the documentation, which is also here, so let's open it. No, where, yeah. blah, blah. Okay, let's go from the slide. All the documentation is there, but it's not very well organized. We have the first constructor. You see the keyword new means we are talking about a constructor function. The construction function is called database inside the SQLite module. Okay, so we are building a new object of type database by providing the path where we want to store the data. Okay, so const, let's copy db new SQLite.database, and then you provide two arguments, a file name and a callback. It's an asynchronous operation. The file name is where we want to store the data. And the callback is the function which is called when the operation is finished, so when the database is open. So in this case, the signature is error. So where is that? You see that the signature of the callback is a function that receives one argument, which is an error object or null if there was no error. Okay, like the convention. So we can error, and then we can have some message like if not error, console.log db opened successfully. Okay, if you run, okay, it took some time to initialize the database, the debugger, and so on. So at the end, this callback has been executed with an error of null, so there was no errors actually. And I see that in my folder there's a new file called data.sqlite, which right now is an empty file. There's nothing inside. If I tried, let me try, I don't know if it's work, to create some strange file, probably I should get an error. Okay, I'm not managing the error, of course, stupid me. Yeah. In this case, if error is not null, it means that something wrong happened. And I can here print the error message. Error is an object that can serialize to a string message, or you can also see the different properties of the object. In both cases, DB, you see, this error processing is asynchronous. Happens when the database is being created or opened and so on. But synchronously, we are storing this DB object. Let's focus on the sequence of operations. We call new function. This is a synchronous function call. I'm creating an object, a normal constructor function, with an argument that will start an asynchronous operation and immediately return a value before the asynchronous operation is completed. Then the operation will go forward, and when it's finished, the callback is called. So the value of DB is set before the actual database is open. So even in the case of if I'm printing here this DB, you see that what I'm printing here at line 10 is printed before the other messages, right? And because line 10 is a synchronous operation after line 3. Here we have only 3 statements, line 1, line 3, line 10. They are executed synchronously, compactly, without an interruption. So in line 10, what I know is that I have an object with a file name, with a strange file name. It's wrong, but I don't know it yet. And right now it's not yet open, of course. Then, asynchronously, okay, we will execute this, and in this case we have an error. If I try to, I'm not sure it works, but let me try. Also to print db here. I'm not sure if the variable has already been created here, but let's see if the closer is working. Yeah, again, it's the same object being printed here, but later on. In the case everything is okay, so let's put it again with a same name. Of course, let me put some braces. Okay, so let's look at the sequence of messages. First, we have this print from line 13, file name, open false. It's not open yet. Then the operation happens, the callback is called, and when I print the object db from line 6, you see, print from line 6, it's open now. Okay? So we just need to get used to different order of execution. Okay. Now what can we do with a database? Well, if it's empty, we cannot do too much. If you want to be, I installed in my VS Code an extension which is called, maybe I can suggest it to you, is called SQLite tree editor. Okay, by a strange person. I was a bit wary of installing that from WA1-2026-L06 as a user, but it works well. And it's a graphical editor that can help us see and query and also manage and modify SQLite data. Okay, so if you, after you install this extension, there are a few extensions over there for managing SQLite files. I found this one, which is a good compromise between functionality and weight of the extension. So right now we see that the database, there's no tables in this database, it's telling me. We could create some table, insert some data just to play. We could do that with code, but probably it's easier to do that in the interactive mode. Okay, so let's create a table, I don't know, users, with some column which is an ID. That can be an integer, primary key, okay, a second name, which is a text, not primary key, and a column name, email, for example, or something like that. Create table, where is the button? Okay, commit. Something very simple. Okay, so we have a table right now with 3 columns, ID, name, and email. And I can put some values. For example, here, say, with this resolution, it's not very easy to see everything, but okay, we have maybe ID 1. The name is Fulvio, the email is mine. And then I can have another ID of 2. We can set that also as an auto increment ID, but just for this, just for putting some data inside. Okay. And then we can have number 3. You see that it's auto-incrementing. Or whatever. Okay, I just put in there some data inside the table. How to query this? So right now I have a database that has been opened here in my index.js file. I want to make I extract and see the list of all the names, for example. So there is a db.all. All the db is the database that we just opened. We have a bunch of methods for querying that, for running queries. All, get, each are all queries for select statements, for reading data. The difference is that all returns all the data corresponding to a query at once. Get returns only the first result, and each returns one result at a time by calling a callback for each of them. Let's see that. And the easiest one is all. So let's see, I want to see all the names in the database. Good. So I db.all, and I have two arguments here, the SQL statement to execute, and the callback to run when the SQL statement has been processed, all with the same pattern. So now I want to select all the, what's the, sorry, name over fields, no, name from users. Okay, select name from users. And then, when the query is over, I execute something. The callback function has two arguments. The error, by convention. First argument is the error. Second argument is the data. The data rows is an array of items, and each item is a result row. Let's see. Error rows. Then here we have the code that we execute after the result returns, and in this case it could be just if error. If I have some error, I don't know anything better than writing the message out. Else. Let's see how rows is constructed. Of course, I'm just doing console.log_error. In a real application, I should throw an exception, okay, that somewhere I will manage. And what we had here, sorry, the console is just trying to show what I just need to keep I need to keep the process alive with a breakpoint so that they can see also the data. Because otherwise, if printed this and try to expand that, the program is not running yet. And sorry, where's the run? This okay. Sorry, if I put a breakpoint here, the program is stopped before the asynchronous code is executed. Yeah. So I need to put it here. Okay, rows. Now I can see it. So error was null, as we expected, And the rows is an array of 3 elements, and each element is an object. And the object corresponds to a row of the result set, not to the original table of the result that the query defined. The value is the name of the column, and the value, of course, is the value of the field. So if I wanted to have also the ID, I would modify the query, and at this point I have 3 objects, each of them with ID and name. We see that the name is a string, ID is a number. You see there are no quotes, because in the database we defined this column ID as integer, so the SQLite library maps to a number, otherwise it will map to a string. Okay? So we can do whatever we want with this rows statement, rows value. Just remember that rows is only available inside this callback. If I try to print something here, okay, how many users do we have? Const number of users could be rows dot length. And it doesn't work. It doesn't work, first of all, because rows is not defined. Rows here in line 20 is not defined because rows is an argument of a callback function. Only exists between here and there. Yeah, but we are more clever. Let's make the callback store some value outside. We are using closure, okay? So let's say let saved rows whatever, and then we can do okay, so it's a way of exporting some data which is available in the callback to the main program. It doesn't work, of course. It doesn't work because if we initialize this with null, here it will still be null. Sorry, not saved rows. It will still be null. Because synchronously nothing happened. If you're not sure, cannot be the property of null. So we are trying to get the length of a null. Saved rows is null. So there is really no way of getting data that we know from inside the callback or getting this data out of that callback. Because out is before. Whatever happens here in line 24 and next, all these code will run before the query is started. So that's why I was telling before, when you have an asynchronous callback, then after that you have nothing more to do, if you depend on the result of that code. Okay? And everything else should be done inside here. Maybe I have a second query to do. Okay, let's start the second query there, inside the callback of the first one, because then we have the result. And the callback of the callback will process the results of the second query. We are forced to nest inside of each other different callbacks in order to preserve the sequential order of operations. Okay, because the code after this query is executed usually is inside the callback, not outside. And so if we need to do something after, we need to do that inside. At least until we learn another couple of keywords that make it easier. But the concept is the same. Okay, this was the all. What do the other do? Get only returns one row. So if I modify this with instead of select.all with select. So let's remove all these half-brained attempts at doing something impossible. So let's get, we'll only get one row. An error somewhere, sorry. Yeah, I didn't remove all the noise. Okay, so in this case we see that in the first print here I have the three objects that we saw before, and in the second case I have a single object. The first one, just remember that first is arbitrary because we are in a relational database, so unless you put an order by clause you don't know which is the first. Okay, first according to which criteria. Normally it's the order of insertion, but if you delete and insert something, this order may break. So just if you need the first element, either your query only has one by construction, or so you can just get the first one. Imagine you have a count statement. A count statement always returns one row, and so you can extract it with get without having. With all, you would have an array with one element, and this one element is the count. Here we just get the object. And the other alternative is, so in this case, when you only need the first element, and so please use an order by clause. Or your query has at most one element, you can use get. What happens if I don't have any results? Where ID greater than 10. This would return 0 results, right? It's undefined. It's not error. The query is not wrong. The result is empty. The result set is empty. Getter returns undefined in the callback, which is a bit strange, but and in the case of all, is more natural. It would return an empty array. Yeah, an array with 0 element. That's normal, no? How many rows do you have? 0. Okay, the result is an array with all the rows, 0 rows. In the case of get, where the documentation says it will get you the first result, there's an exception when the first result doesn't exist. Okay, so let's remove that. So just remember, it's not an error. It may happen. It doesn't create error, just doesn't provide you any result. So we need also always to check for corner case, how to deal with corner cases, how the library interprets the corner cases. And the each statement, the each method of the SQLite database, it tells me execute the callback, so the signature is identical to get, and it takes one row, but if there are more rows, the callback is called many times. So in this case, I have, this was the call for the get, and these are the 3 calls for the each. By the way, you see that the, yeah. What is interesting, look at the lines here, at which the console.log were issued. The last one, the last that was printed, was actually the second that we defined. First, the print was from line 17, so the result of the db.all. Then we have some lines, 1, 2, 3 here, that were printed from line 33, which is not the second, it's the third query that we run. And so we are printing these ones. And finally, we are printing the result of the second one. It's asynchronous. It runs in the order it wants. Okay? So we cannot expect to have the results before the code is completed, of course, but if you have many asynchronous calls, they can complete in different orders. And we have no control over them. Okay? We just need to be aware of that. By the way, there's nothing against having a mix of the two. Each code calls many times this callback, but there's no guarantee that they are all called consecutively. They are called in order, of course, the first, the second, the third, but between the second and the third, something else may come in the middle. Each callback is independently scheduled. Okay? So, if we want to be sure of an execution order, we must put the second instruction in the callback of the first. That will only be executed sequentially. Otherwise, there's no parallel execution here, but there's an asynchronous happening of the results. And this can, okay, there are, about SQLite, okay, there are other statements, but the most important are these ones. For querying, we select. In the case we have to do other operations like creating tables and so on, we have another statement, especially insert, which is called run. Now, the difference between run and the query statement is that the query statement gets return you in the callback data, and all the other statements in SQL don't return any data. They just do something, and you see that the callback, the difference is that the callback only takes one argument, which is the error code, but there's no data. And the other interesting point is what happens if we have some parameters in the query. So maybe we want to select only information about user number 2. Okay? But this 2 is a variable in my code. There's a nice mechanism for parameter substitution where we can put a question mark whenever we have a variable value, a parameter to substitute, and then provide the values of the parameters outside the function in a second argument of the callback. So actually the callback receives 3 arguments, right? Error, parameters, which is an array, callback, which is a function. And what happens is that the values, the actual values of the arguments that we have here in this array are substituted one by one with the question mark that we have in the code. So this means that it's a good mechanism. It also prevents SQL injection, because there's no risk that the user types in some value which is interpreted as SQL syntax. It's protected with this mechanism. So don't use, when you need to pass some parameters to a query, never use string concatenations or template strings. Okay, that just interpolate the string inside, and if this string that maybe comes from the user contains some special characters, some apostrophes, some comment signs that could be interpreted by the SQL interpreter. Always use this mechanism for giving the parameters that, of course, they should be of types that are compatible with the query, so integers or strings. Okay. Just remember, even if you have only one parameter, always put them in bracket because it needs to be an array. The array is the mechanism by which the SQLite library understands whether the second parameter is the callback function or the list of arguments. Because if you don't have the list of arguments, you have the callback will be error, callback. If you have arguments, we have error, arguments, array, callback. So the second argument may have different meanings depending on what you specify. The implementation of get, or all, or each, should check the type of the second parameter to understand whether it's a list of parameters. So it's you know, a trick of the library that requires braces also if you have only one parameter. Okay. Well, there are some examples, but yeah, here we have another example similar to what we tried before of trying to pull out the data from the callback, which is not possible. In this slide, we are trying to say, okay, when you have dp.all, we have many rows, and each of them we can put them into a result array or somewhere, but we cannot use it outside. And also, we cannot return this data. Here, let's say, let's take the first one, db.all. One person could say, okay, but return rows. So we can return the rows to the caller. Actually, it doesn't work, because the caller of this function is .all, which doesn't do anything with our return value. We cannot return, you know, there's no way of saying const result equal to. Okay, that would be having the result synchronously from an asynchronous. In fact, well, in this case, the result of db.all is the database object itself. So there's no information there. Okay, so don't try that. It never works. You cannot make it work. The only place where this information exists is inside the callback. And this can lead to some strange behaviors. Just to be familiar with the asynchronous operation. I try to make some stupid case in which I want to increment the number many times. Okay? So I create a table with one field number. I have a query to add the one number, so it will be a table with many one in many rows. Every time I do this insert, a new line appears. And then I can do the count, okay, for the number of rows that will tell me how many ones I have in the table. And in my mind, I want to have a loop that alternates an insert, a count, an insert, a count, an insert, a count. So I should potentially see an increasing sequence of integer numbers. I insert 1, print count 1. I insert another number, I print the count will be 2, and so on. But since these insert and selects need to be run inside the asynchronous statement, this will be the code corresponding to what I thought before. So, okay, I have the database. I have a loop of 100 iteration, which I run an insert, and then I run the count. And then I iterate and I repeat again. The issue is that the word then that I used is not in the code. Okay, so what I'm doing here is I'm executing 100 times this insert statement, and I'm executing 100 times this select statement that will print some value in the console, but I don't know in which order these two will be executed or mixed. I could have maybe an execution stream where I do first all the 100 insert and then all the 100 selects counts. It's not impossible. Or one by one, or they can overlap in some way. So I really ran this code, and this is what I got. 89, 90, 91, 92, good. Oh, 96, 96, 96. 97, 98, 99, in this case it was run for 400 times. So in total, I ran the exact number of queries, and I did the exact number of inserts, but they were not alternating. we cannot rely on this second query to be executed after the first one completed. The only way would be to put this query inside the callback of the first one. But we also want to execute the insert after the select is being executed. So I would like to have, okay, this is what may happen, is in overlapping of the query execution. Actually, what I want to say is that the second query should be inside the callback of the first, but also the first query should be inside the callback of the second, if I want to be sure that they are executed in sequence. And of course, topologically, this doesn't work. You cannot be inside and outside at the same time. This is not a limitation of the mechanism of callbacks, it's a limitation of the nested syntax, no? Or the structured syntax of blocks. So it's not impossible, it takes a lot of code to do that properly, because basically you need to synchronize externally with a loop that say, okay, now is your turn, now is your turn, and so on. But basically you are doing some scheduling yourself, okay, which is not, and this is why what they called in JavaScript programming, they call it callback hell, okay, because you have a callback inside a callback inside a callback, and then you should go back and you don't know how to do that. And this is why over the years they try to develop a new method for managing these callbacks by trying to first abstract over what you really want and give a simpler syntax for getting it, for obtaining that. And this is called promises. So, okay, for interacting with the database, it's perfectly fine to do, in normal cases, it's perfectly fine to work in this way. Okay, first of all. So if you don't need to do anything complex with strong dependencies, it works quite well. I don't know, imagine an API server. When you hit on a server to get some information, you just need to run a simple query or two, but you can nest them and you have the result and you're done. But in more complex cases, to fight this callback hell mechanism in which we have the callback of the callback of the callback, even for easier cases, no, they invented this new type of object which is called promise. A promise is an object in the JavaScript standard library that abstracts what you want to do with an asynchronous operation. And basically, with an asynchronous operation, you want to do three things. Start it, do something when it ends, do something when it fails. Okay? So this is what a promise object gives us. It's an object that represents an operation which is currently ongoing, that may fail or may succeed, and or may not complete. It may complete or not. Maybe when the user clicks on buy, the user will never click on buy. Okay, it's a promise that is never fulfilled in these terms. So you create a promise object. It would be, you specify which operation needs to be done, and this promise object, which is an object is created synchronously. Remember the DB object in the database. I'm creating the object synchronously, and then the content of this object will evolve asynchronously. So you create a promise now, and it will be in a pending state. I don't know yet. Then, maybe later, this promise will fulfill, will succeed, or will fail. So the syntax is very easy. The object is called promise, so we create a new object with a constructor function, and it receives only one argument, that is a callback. The callback containing the code that we want to execute asynchronously. So we do some code, and then inside my code I can call two special functions. They are not special at all. Two functions that are the arguments of my callback. It's late, it's difficult. It's not difficult, but we are creating an object that gets a callback function. The arguments of these callback functions are two functions. Normally we call them resolve and reject. You can call them A and B, don't. Okay? And this function will be, so our function is the callback of promise. The arguments are callbacks of my function. And so in our code, we can do whatever we want that will happen asynchronously. But if at some point we call the function resolve, which is not a function that I write, it's a function provided by the promise library, but I call this function with a value, this will be the value resolved, fulfilled by the promise. They use these terms, fulfilled. If I call reject, then this promise fails. And they can give some motivation, some error message, some error object for the reason why it fails. Okay, so in my code I do something, and I may call resolve and reject to finish this promise. Can be completed or can fail, depending on what I call here. This is one side, where I define the asynchronous operation to do. There's the other side, if the caller that uses this operation, what can it do? To extract from the object. Let me do one step at a time and try to convert this first db.all into something with promises. Okay? So let's write it at the end. So I need to, again, extract a list of names. Fine. Const name list, names, new promise. Promise me that you will give me the list of names. Okay, I do. I promise. Inside, I have a callback that will try to fulfill this promise. Resolve reject code, and here we have all the code that hopefully contains the result that we want. Okay, so the code is computing all the database, so we can do whatever we want. db.all of my query, which is the same as before, only with the names maybe. I don't need the IDs. db.all, and then I have the callback of db.all, error, comma, rows, and then I have the callback for itself. So, what do we have in the callback of the promise? db.all, the launch of the query. Inside this query, which is asynchronous, it will have its own callback that is activated when we have the result or the error. So at that point, but here, at that point, since you are inside the promise, we have a mechanism for pulling the data out, which is if error, reject. As we have the data that we can call resolve. Well, now we have an array of objects of type names I don't want an array of objects, I just want an array of strings. Maybe I promise to give you an array of strings. So let's do some computer return, resolve. I don't know, the rows, where maybe I want to map each element R into just its error.name. So imagine resolve as a return from promise, and imagine reject as a throw an exception or an error from a promise. It's the same code as before. We wrap them into a promise object. Inside the promise, we have the execution. Outside the promise, we will have, now we'll see in a second, the way of extracting the result of this execution. Okay? So, again, every time I need to do something asynchronously, I may use this promise object by writing any code I want, can do that, do things synchronously, asynchronously, how they want. You see that, for example, here we're using a closure, no? Because inside this callback, we are using a parameter which is defined in the enclosing function. Everything falls in place. We don't notice anymore, but it's there. The closure mechanism that was strange before, now we are using it normally. Later on, when this callback will be executed, I need that argument, that function, okay? Reject or resolve. Okay, inside the code, the important thing is that sooner or later, I call resolve or I call reject. Otherwise, the promise will be in the pending state forever. And now, synchronously, let's go out of the promise. Synchronously, in line 48, names. What does it contain? Nothing. Nothing. Because synchronously is just a promise that just created without any chance of being executed. But here, this object is there, is alive, I can store it somewhere, I can sparse it around, I can return it to my caller, or whatever. It's an object that gives me the possibility of extracting the value. Maybe not even here, even in some other part of the code. So it's a handle for getting the results. And how to get the results out of a promise? There are two ways. The simplest one is two methods, then and catch. So then is a method that is called when the promise is fulfilled. Catch is a method that is called when the promise is failed. And for each of them, of course, you have your callbacks. Then is a method that can be only executed asynchronously. Then the callback for the then method will be executed if and when the promise fulfills. The callback of the method, we are registering here now a method to be executed when the promise will fulfill. And the same when the promise will fail. So in this case, it could be just a callback that takes the result and prints it. And the catch callback the catch method, let me specify what do I do in the case of an error. Of course, I didn't resolve the problem at the root, because this code for using the result is not longer, is not more synchronous than before. It's still asynchronous. But I decoupled the part of the program where the query happens from the part of the program where I want to use the result. And I can move this around. I can put the query database inside the function. And the function will not return a value because it can't, but it will return a promise. And so the caller will have this promise, and when it needs, it just extracts the result. Of course, when I call then, I should expect my program to wait, to be put aside until the result will be executed. Okay? So this is the basic mechanism. In this case, of course, it will print, you see here the last line, a list of strings, no longer a list of objects. So this is working with our map worked. It has been printed later, so we are extracting that. This is just the first flash, the promises. Of course, next week we'll start using them better. The syntax is much cleaner, okay? Because you see here, I only need to compute the result. I don't need to know how to use it. I don't need that this code inside here, inside the callback, knows what to do with the result. Because that would be a problem. Putting some logic inside the query logic. We have the query, and then we have the mechanism of applying some logic on the result of the query. And the way to transfer them from one part of the other. On Friday, the exercise will be much easier. We still don't, in the lab of next Friday, we still don't use this stuff. We'll continue next week on that. Okay? Have a nice day.